Walk into any chemistry laboratory today, and you expect exact measurements and predictable outcomes. But for centuries, human beings saw bubbling liquids and sudden color changes as uncontrollable acts of magic. Early alchemy ran on a messy blend of secret rumors, incomplete observations, and theories that no one bothered to verify. As long as natural reactions were treated like magic tricks, uncovering the physical laws governing them remained impossible. Then, an 8th century scholar named Jabir ibn Hayyan looked at this chaos and demanded a rulebook. His philosophy was strict: reject all old beliefs in favor of direct, personal observation. To achieve this, he created a dedicated, highly controlled workspace, distinct from the secretive dens of the alchemists. Inside that space, theoretical assumptions were set aside. Every single chemical reaction had to be physically tested. By requiring physical proof for every claim, Jabir established a new standard for investigating the material world. This systematic labeling shows a shift in thinking. Materials were finally being treated as physical objects with specific properties, rather than magical artifacts. On Jabir's workbenches, raw materials were systematically heated, cooled, mixed, and dissolved to measure exactly how they behaved. He isolated specific reactions by filtering and purifying these substances, stripping away unknown variables. These actions were performed under strictly controlled conditions, ensuring the outside environment didn't skew the results. Breaking raw materials down into measurable, isolated properties provided the data required for scientific classification. To ensure his results were accurate, Jabir deployed a powerful tool: active skepticism toward his own work. If a reaction worked once but could not be repeated under the same conditions, the result was discarded as invalid. To solve this major problem of repeatability, he therefore required exhaustive documentation. He recorded the exact procedures he took, step by step, alongside the resulting evidence without bias. He realized that a successful experiment holds zero scientific weight without the records required to prove it actually happened. Because Jabir wrote down his precise procedures, outside scholars could independently verify his results. Once a result was verified, new researchers could safely build subsequent experiments on top of it. This continuous cycle of shared verification and iteration became the basis for the modern scientific method. The goal of the discipline moved from hoarding secret knowledge to creating a shared, verifiable public record. Centuries later, we have more advanced tools, but the logic of chemistry remains the same. Every modern laboratory still operates on 4 principles: observe carefully, experiment systematically, record the results, and trust the evidence. Jabir discovered dozens of specific chemical compounds, but his primary impact was defining the process used to find them. Jabir ibn Hayyan moved chemistry from the realm of mystical art to the world of experimental science.